Hi everyone. So I am not with you today, but you have an amazing sub there that currently has your 5.1 homework that you did fully and feel comfortable with. You also got the packet from the sub on these 5.2 notes. So this is what we are going to do today. All right, we will learn how to apply sum and difference formulas for sine and cosine and tangent towards finding the exact value of trigonometric functions that are not necessarily special angles found on our unit circle. Now, what does that mean? Basically, we're going to use these little formulas here, which I will give you on your note card. Not your note card, your reference sheet, right? That I'm going to give you. These four will be there. Basically, if I have something like sine of 75 degrees, well, I don't have 75 on my unit circle, but two angles that are on my unit circle that can make 75 are sine of, I could use 30 and 45. So basically we could still use our special angles from our unit circle to solve for other types of trig function values using these formulas right here. Okay, so that's what we're going to work on today. So 1, I can apply the appropriate sum or difference formula to calculate the exact value of a certain trigonometric function. 2, I can accurately prove that a trigonometric equation is an identity through application of sum or difference formulas. We can use sum or difference formulas within our trig identities as well, okay? These are technically identities, so we can use them to verify anything. Now, with this video, please feel free to pause at any time, write through your note packet that you got from the sub that goes with this, okay? Make sure to fill these out, okay? We're not going to miss a beat just because I'm at a conference. So, we have our four formulas, okay? We have cosine of angle A plus angle B, okay, or alpha beta, and it equals cosine alpha cosine beta minus sine alpha sine beta. Cosine alpha minus beta, it's the same thing as the plus, just they switch signs, okay? Sine alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. And with the minus, same thing, just switching signs. Again, you don't have to remember these formulas, but you're going to use them a lot where it's just going to become repetitive, and you're going to start to remember them without even trying. Now, the most beneficial tip for using such formulas is to find two angles from your unit circle to add or subtract to get the given angle. So, we're going to use the sum or difference formula to find the value of cosine 15. So when I say find the exact value, you should always be looking to your unit circle, okay? And to your identities to figure out what angles can I use for my unit circle and within what formula to get cosine 15. So, cosine of 15 degrees, okay? Think about it. What two angles on my unit circle will make 15 degrees, whether adding or subtracting them? Oh my god. Ignore the fantasy football updates. I can get 15 degrees by doing 45 minus 30. So those are two angles on my unit circle, right? So I'm going to plug them in. So cosine of 15 degrees is the same as cosine of 45 degrees minus 30 degrees. So I'm doing cosine of an angle minus another angle. So my alpha is 45 degrees. And my beta is 30 degrees. And I'm doing the cosine alpha minus beta formula. So, let me look up here. I'm going to have, for the minus one, cosine alpha, cosine beta, plus sine alpha, sine beta. So, cosine alpha is 45, cosine of beta, which is 30, plus, it's actually weird because you're like, oh, it's minus, it should be minus. No, the formula says plus, use the formula. Plus sine of 45 degrees times sine of 30 degrees. So from here, all you're going to do is look at your unit circle and find those exact values and plug them in and simplify. Please remember, on your unit circle, cosine is x, sine is y. So cosine of 45 degrees, we should get square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. Yep. Plus sine of 45 is square root of 2 over 2, and sine of 30 is 1/2. From here, forget the fact that we're doing trig. Just do some multiplication, okay? PEMDAS. So square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. Plus square root of 2 times 1 is the square root of 2 over 4. So that means that when I, luckily common denominator, so I get the square root of 6 plus the square root of 2 all over 4. Or you could also see it written as, technically this is 1/4, because dividing by 4 is the same as multiplying by 1/4, right? So 1/4 times the square root of 6 plus the square root of 2. This is the answer, either one, for cosine of 15 degrees. So, if you need a minute to pause and kind of look it over and be like, okay, does this make sense? Go ahead. Okay, so this is cosine of 15 degrees. Now, if I give you a formula like this and I say find the exact value of cosine 80 plus times cosine 20 plus sine 80 sine 20. Those are not unit circle angles, so how am I supposed to do this? Well, just look at the formula, okay? We have cosine of one angle times cosine of another angle, right? Plus sine of the first angle again, sine of the second angle. Basically, if my alpha was 80 degrees and beta was 20 degrees, I have cosine, cosine plus sine, sine. That is the cosine alpha minus beta formula. Okay, look to see, does this look like one of your formulas? If so, utilize that to condense it. You can expand just as much as you can condense. So, really, this whole thing is the same as cosine of 80 degrees minus 20 degrees, which 80 minus 20, cosine of 60 degrees. So cosine of 60, let me look at my unit circle, because that's an angle on my unit circle, and I get 1/2. Done. Now, I know you could just plug this into your note card, plug this into your calculator, but please remember, you don't need your calculator for everything, okay? Just see the connection, see the pattern, what formula does this look like, and condense it. With all these formulas, if you don't see angles that are on your unit circle, you probably have to expand or condense with the identities, and then you'll end up using a unit circle formula angle every time. Okay? Whenever I ask exact value, you're going to need a unit circle angle. If you don't have one, manipulate it. Look for a formula. Okay. Now, verifying an identity. So if I ask you to verify the identity, cosine alpha minus beta, all over sine alpha cosine beta equals cotangent alpha plus tangent beta. Now, I know we just spent a lot of time practicing verifying trig identities. Remember the big rule, know your identities and work with the uglier side. I suggest work with the left side. So, I'm just going to do it this way. So, cosine alpha minus beta all over sine alpha cosine beta. So what I'm going to do is I'm going to expand that numerator, okay? I'm going to plug in the cosine alpha minus beta formula. Now that formula is cosine alpha cosine beta plus sine alpha sine beta. Now put that all over sine alpha cosine beta. Now please do not sit there and be like, okay, let me cross out here and here, and then here and here, and I have cosine alpha sine beta. No. Please do not do that. Okay? We need to remember that we are dividing this from both pieces in the numerator. So technically I need to write this as cosine alpha cosine beta divided by sine alpha cosine beta plus sine alpha sine beta divided by sine alpha cosine beta. Now you can start crossing things out. So cosine beta crosses out, sine alpha crosses out. So basically what I'm left with is cosine alpha over sine alpha plus sine beta over cosine beta. So we're so close. What's cosine over sine? It's cotangent. Of what angle? Alpha. Plus, what's sine over cosine? Tangent. Of what angle? Beta. That is why I always stress when you did trig identities, you can't switch it to x. You have to keep it theta if they gave you a theta. If they use alpha, you gotta keep it alpha. Because when we get into using different types of angles, you're gonna need to know the difference between the two angles. So please keep it this way. So I verify because it now looks like my other side. And just take a minute to pause, kind of look it over, make sure you have everything, and then we will move forward. Now, find the exact value of sine 7 pi over 12. Ew, they're in radians. But I was super nice in this problem and said, using the fact that 7 pi over 12 equals pi over 3 plus pi over 4. Okay? If you would like to change its degrees to kind of help yourself out, okay, but you need to keep them in radians. You need to get comfortable with them. They're not going away. Remember my story about college math, okay? The radians don't go away. So, basically it's saying sine of 7 pi over 12, okay, is going to be the same as sine of pi over 3 plus pi over 4, okay? Now, I see sine with plus. Now that identity is going to be sine of the first one. Well, your first one is pi over 3. Your second one's pi over 4. It's sine of pi over 3 times cosine of the second one, pi over 4, plus cosine of your first, pi over 3, times sine of your second, pi over 4. Now, remember pi over 3 is the same as 60 degrees, and pi over 4 is the same as 45 degrees. So, sine at 60 degrees is going to be square root of 3 over 2. Cosine of pi over 4 is square root of 2 over 2, plus cosine of pi over 3 is 1/2, and then sine of pi over 4 is square root of 2 over 2. So, from here, do some PEMDAS, simplify your answer as much as you can. So I get the square root of 6 over 4 when I multiply here, plus square root of 2 over 4 over here, which can then be combined so that sine of 7 pi over 12 can be written as the square root of 6 plus the square root of 2 all over 4, or 1/4 parentheses square root of 6 plus the square root of 2. Now, let's pause for a second so that we can look at this problem here. So, these problems every year, don't ask me why, okay? People struggle with them, okay? Now, you shouldn't struggle with them because you're given enough information to find all these pieces, okay? Now, your two separate angles, they're not from the same triangle, okay? They are their own triangles on their own when it comes to our SOHCAHTOA stuff, okay? So use that idea in order to help yourself out, okay? We're kind of going to tie in a little bit of what we did last chapter with this chapter. So suppose that sine alpha is 12 over 13 for a quadrant 2 angle alpha. So that told me sine at the alpha is 12 over 13, and the alpha angle is in quadrant 2. So it kind of helps me figure out what my sines are. And sine beta is 3/5 for a quadrant 1 angle beta. So beta's a quadrant 1 angle, alpha's a quadrant 2 angle. It says find, now we got to find the following things. Now this is what I suggest. Let's write out the formulas first. For cosine alpha plus beta, we're going to want the following. We're going to want cosine alpha times cosine beta minus sine alpha sine beta. For sine alpha plus beta, it's going to be sine alpha cosine beta plus cosine alpha sine beta. Now, let me plug in what I already have. Okay, so I have sine alpha and sine beta. So I only really have these parts of the formula. Same with this one here. I only have these pieces. So I have to find those other pieces. Now the only other way I can find those pieces is by drawing my right triangle like I did last chapter and doing SOHCAHTOA. Okay? So what I'm going to do is for alpha. Okay, it's a quadrant 2. So quadrant 2, we're looking at alpha. So I'm going to draw a right triangle. Now your alpha's here. Now I have sine alpha, right? So sine alpha is 12 over 13. What two sides of my triangle does that give me? It gives me my y and my r, right? My opposite and my hypotenuse. So I have 12 and 13 here. Okay? Now remember, in quadrant 2, we have a negative x and a positive y. Okay, so my y was positive, my r is always positive. Now I just need to find my x, and I know it's going to be negative. I just need to use my quadratic formula. Not quadratic formula, we're long past that. My Pythagorean theorem to find my answer. So 12 squared is 144, plus x squared equals 13 squared is 169. And minus 144 from both sides. And I get x squared equals 25. Square root, x equals 5. Now we know x is negative 5. Okay, so we found our x. All we really need is cosine alpha, right? So that's going to be negative 5 over 13. So I could take that piece and plug in it. So I plugged in that piece. Now I did that for alpha. I still need cosine beta. So I'm going to do the same thing I just did with the alpha. I'm now going to do for beta. Now my beta information, I knew quadrant 1. And beta, in quadrant 1, remember everything's positive. It's a positive x and a positive y. Let me make that neater. And I knew sine beta was 3 over 5. So again, I have my opposite, my y, and my r is 5. Now, some of you already know this because it's a Pythagorean triple. Your x is going to be positive because we're in quadrant 1, and it's going to be 4. But if you didn't know that, remember 3 squared plus x squared equals 5 squared. 9 plus x squared equals 25, minus 9 from both sides. X squared equals 16, I square root, x equals 4. So I'm done. Pythagorean theorem, and I got it. So now that I have that, cosine of beta has to be my x over r, so it's 4 over 5. So I'm going to take that information I found and now plug it into the formula. There was a plus there. Now that I filled in all my little pieces, I could finally solve. Okay, I'm always going to give you enough information. Like I said last chapter, if you're always given one trig function and the quadrant, you will be able to find the rest of the trig functions for that angle. So let's simplify this a little bit. So negative 5 times 4 is negative 20. 13 times 5 is 65. Minus 12 times 3 is 36. And then 65. Negative 20 minus 36, we get negative 56 over 65. And I can't simplify that anymore. So that's what cosine of alpha plus beta is. Negative 56 over 65. Now for sine. 12 times 4 is 48 over 65 plus negative 5 times 3 is negative 15 over 65. 14 plus negative 15, so it was really minus 15. We're going to get 33 over 65. So I found the A and B, right? I have no problem with that. Now for C, when I say what is the quadrant for angle alpha plus beta? Well, remember last time, whenever I asked for a quadrant, we always went and drawn out the all students take classes, right? You're still playing process of elimination, but you're going to use your answers from A and B in order to answer this. So let's look at B. So our cosine of that angle was negative 56 over 65. So it was negative. So I can't fall in the fourth quadrant or the first quadrant. Now, sine of that angle is 33 over 65. So it's positive. So out of the two left, I can't fall in the third quadrant. I have to fall in quadrant 2. So once you have your two trig functions for that specific angle, then you can solve this, no problem. Now I want you to pause real quick, take all this in, and I want you to try the checkpoint. Okay. Hopefully you did pause. If not, that was a very short amount of time to be doing the problem. So let's look at this. Suppose that sine alpha is 4/5 and for a quadrant 2 angle. And sine beta is 1/2 for a quadrant 1 angle beta. And I gotta find the exact value of each. So the exact value means I gotta write out the formula and plug in all my pieces. So cosine alpha plus beta. Alpha minus beta, I mean. So we have cosine alpha, cosine beta, plus sine alpha, sine beta. Well, the only pieces we were given so far was sine alpha was 4/5 and sine beta was 1/2. With sine alpha minus beta, that formula is sine alpha cosine beta minus cosine alpha sine beta. So I can only plug in what I have. So 4/5 and then 1/2. So to find my pieces, I need to draw some triangles. So alpha is in quadrant 2, so we're going to have a negative x and a positive y. I was given sine as 4/5, so that's my y and my r. So 5 and 4, and I got to find x, which I know is going to be negative. And when you do the Pythagorean theorem, you will get 3, so it's going to be negative 3. Minus 16, x squared equals 9, square root, x equals 3. So, sine alpha was 4/5. Well, cosine alpha is going to be negative 3 over 5. So I'm going to plug that into the formula. Now let's work with beta, which is in quadrant 1. So it means positive x and positive y. So we were given sine beta was 1/2. So we get 2, 1, and I gotta find my x, which I know is gonna be positive. So 1 squared plus x squared equals 2 squared. 1 plus x squared equals 4 minus 1 to both sides. X squared equals 3 square root. X equals the square root of 3. I can't simplify that anymore. Also, if you notice that sine beta was 1/2 and you're like, oh, that's on the unit circle, and you figured out where sine was 1/2 in quadrant 1, and then you figured out your cosine, that's fine. You could have done that too. So cosine beta, is the square root of 3 over 2. So I'm going to plug that into my formulas. And now I just got to simplify. So I'm going to get negative 3 square root of 3 over 10 plus 4 over 10. Now don't simplify the 4/10 because they're common denominators. You want to keep that. So we have negative 3 square root of 3 plus 4, or you can write it as 4 minus 3 square root of 3 over 10. Now remember, you can't simplify because all three numbers don't have something in common. Remember that whole Holy Trinity thing I talked about, right? So cosine of alpha minus beta is going to be 4 minus the square root of 3 over 10. Now 4 minus 3 square root of 3 over 10. So when I do the next one, 4 times square root of 3 is 4 square root of 3 over 10. Minus, minus a negative, right? Because it's going to be negative 3 over the 10. The double negative becomes a positive. So I'm going to get 4 square root of 3 plus 3 over 10. Or you could write it as 3 plus 4 square root of 3 over 10. Doesn't matter. It's the commutative property. My math lab, either one will give you the right answer. Now, when it comes to figuring out the quadrant, I know it's not as easy as it was before because you're like, well, I have radicals. If you want to figure out what they are, just plug it into your calculator. Okay? So when we do, let's see, 4 minus 3 square root of 3 divided by 10, you're going to get a negative number. Okay? Now, when we do 4 square root of 3 plus 3, obviously it's a positive plus another positive. It's going to stay positive. So, our answer here is going to be positive. So, when it comes to figuring out the quadrant, cosine is negative, and sine is positive. So, we got to be in quadrant 2. Take a chance, pause, make sure you have everything, look over your notes. And now, obviously we talked about the sum and difference formula of sine and cosine, so obviously there has to be one for tangent as well. So, tangent of A plus B is going to be tangent of alpha plus tangent of beta minus 1, all over 1 minus tan alpha tan beta. And then tan alpha minus beta, they look the same, it's just they switch. Okay, so it's tan alpha minus tan beta all over 1 plus tan alpha tan beta. So, if I asked you to verify this identity, verify the identity tangent x minus pi over 4 equals tangent x minus 1 over tan x plus 1. Now, I know I said work with the uglier side, but if we have two angles within the parenthesis like this, you should work with that side. So we're going to work with this side. So tangent of x minus pi over 4. So we're going to do the tangent difference formula, right? That we just have up here. So it's going to be tangent of my first angle, which is x, minus tangent of my second angle, all over 1 plus tangent x tangent of pi over 4. I'm going to simplify all my pieces. Oh my god, someone, hold on. Okay, I'm back. I was so close to being done with the lesson. So, you can only simplify the trig functions that you have angles for. The tan x, that's all you can do, okay? But pi over 4 is an angle on our unit circle, so we can actually simplify that. If you look, tangent is going to be your y divided by your x, right? And the y of pi over 4 is the square root of 2 over 2, and the x is the same. So when you're dividing something by itself, you're going to get 1. So we get tangent of x minus, well, that tan pi over 4 is 1, all over 1 plus tan x times tangent of pi over 4, which is 1. When you do that, when you multiply tangent x by 1, you just get tangent x. And because of the commutative property, you can change it so that the tangent comes first as long as you keep the sign in front. And you just prove the identity. Okay, just use your sum and difference formulas. Once you see something, you're like, oh, I know that's a formula. Just go right to your reference sheet, look at your identities, and see which one you could use for this. Now, I want you to pause and try this one out on your own. Okay, so this is the last one, which makes me very happy. So that hopefully I don't have any more distractions and it won't take you guys the whole block to watch this. So, verify the identity. Tangent x plus pi equals tan x. So, obviously I'm going to work with the side over here. And the identity is tan x plus tangent of my second angle, which is pi, all over 1 minus tan x times tangent of pi. So, well, let me look. Pi is a unit circle angle. My y at pi is 0, and my x is negative 1. 0 divided by negative 1 is 0. It's not undefined. It would be undefined if the 0 was in the denominator. It's in the numerator, so we're fine. So anywhere I see a tangent pi, I'm going to replace it with 0. So tangent x plus tangent pi. Oh, I said I was going to replace it with 1 or 0. I'm okay. So plus 0 all over 1 minus tangent x times 0. Now, tangent x plus 0 is just itself, right? Because anything plus 0 is itself. So it's just going to be tangent of x, which makes us happy because look at what we have over here, right? So we're heading in the right direction. Now, what's negative tangent times 0? Well, it's the same as anything times 0. It's 0. So 1 minus 0. What happened? Okay. So 1 minus 0 is 1, and tangent divided by 1 is tangent. We proved our identity because it finally looks like the other side. Now, look through these notes. Calm down. You can do this. You just added 6 more formulas to your identities. Okay, all the other identities from the last class. Please go now to my math lab and do your 5.2 homework. Don't wait till the day before the test. I want you to do it now. And we're not going to work on anything else like, for example, an A-push reading or an English essay. We're not writing AWPs in here, okay? Do your 5.2 homework now. Then when you finish it with 100, you can then go and do other homework, okay? There is not that many problems in this homework. You could do it before the end of class, okay? Have a good one. Be good to the sub. and I will see you guys when I get back. Bye.